with introduction, the Hadoop ecosystem, common components, and we will try to understand about what is HDFS, Hive, HBase, and Spark. And also we'll try to understand the difference between HDFS and HBase. And finally, we'll finish it off with big data visualization. So beginning with big data may well be the next big thing in the IT world, and it may burst upon the scene in the first decade of the 21st century. The first organizations to embrace it were online and some startup firms, to be precise, Google, eBay, LinkedIn, and Facebook. These organizations were built around big data from the beginning. Like many new information technologies, big data can bring about dramatic cost reductions, substantial improvements in the time required to perform a computing task or new product and service offerings. Big data is similar to small data, but it is bigger in size. But having data bigger, it requires different approaches, the techniques that will be utilized, the tools, the architecture. So, without said, an aim to solve new problems or old problems in a better way is where we can utilize big data. So, big data refers to data set whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. Big data generates value from the storage and processing of very large quantities of digital information that can be analyzed with traditional computing technologies. So, to talk about the impact of big data, the growth is needed and the increase of storage capacity and typically an entirely new source of data. So, increase of processing power and the availability of data. That is, every day we can have somewhere around 2.5 quintillion bytes of data. So 90% of the data in the world today has been created in the last 2 years alone. So how is this all different? So it's like getting generated by a machine. So I can have some sensors that's getting embedded in an engine, and it's entirely a new source of data through the usage of internet. It may not be friendly, and it depends on the values that we are generating. For example, we can talk about the Facebook. It's going to be generating 10 TB of data on a daily basis, and Twitter is generating around 7 TB of data daily. So IBM claims 90% of today's stored data that's generated within this time period. Big data analytics and architecture, you can see it's given about starting on the infrastructure layer, and then there is data monitoring layer, security layer, storage layer, and data processing, and I have data query layer, and finally the data visualization layer. So when we say big data analytics, we are talking about examining huge amount of data with appropriate detailing, identification of hidden patterns and unknown correlations, and it provides that competitive advantage, and you will be in a proper position to take better business decisions. Strategic and operational, effective and marketing techniques can be utilized, and finally you can achieve customer satisfaction and increased revenue. Next is, we'll try to understand what is Hadoop ecosystem. Hadoop is a data management system bringing together massive amounts of structured and unstructured data that touch nearly every layer of the traditional enterprise data stack, positioned to occupy a central place within a data center. So it's a massively parallel execution framework, bringing the power of supercomputing to the masses, positioned to fuel execution of enterprise applications. Hadoop view as an open source community, creating tools and software for solving big data problems. Hadoop generally provides a wide array of capabilities that can be adapted to solve many problems. Many consider it to be a basic framework. Hadoop provides all of these capabilities, but it should be classified as an ecosystem wherein there are many components ranging from data storage to data integration to data processing and to specialized tools which are utilized by data analysts. Next is about the Hadoop ecosystem, and you can see the core components involved in this. So beginning with HDFS, distributed reliable storage, and there is NoSQL database HBase, then programming model, the MapReduce, and the coordination with Zookeeper, and then high-level abstractions, Pig and Hive, and the data integration, Scoop and Flume. We'll see them one by one in detail as well. So beginning with the HDFS, so it's a foundational component of the Hadoop ecosystem. So when I say HDFS, it's Hadoop Distributed File System. So it is the mechanism by which a large amount of data can be distributed over a cluster of computers, and data is written once, but it is being read many times for analytical reasons. It provides the foundation for other tools such as HBase, and HDFS is the default storage file system in Hadoop, which is distributed, considerably simple in design, and extremely scalable, flexible, and with high fault tolerance capability. The HDFS architecture has a master-slave pattern due to which the slave nodes can be better managed and utilized. HDFS can even run on commodity hardware, and the architecture accepts that some nodes can be down and still data has to be recovered and processed. HDFS has self-healing processes and speculative execution, which make the system fault tolerant, and it's flexible to add or remove nodes and increases the scalability with reliability. HDFS is designed to be best suited for MapReduce programming. One key assumption in HDFS is moving computation is cheaper than moving data. So let us see some of the features of HDFS. So starting with scalability, HDFS is scalable to petabytes or even more, and it is also flexible enough to add or remove nodes, which can also assist in scalability. Next is reliability and fault tolerance. HDFS replicates the data to a configurable parameter, which gives flexibility of getting high reliability and increases the fault tolerance of a system, as data will be stored in multiple nodes, and even if a few nodes are down, data can be accessed from other available nodes. Data coherency is the next one, wherein HDFS has the worm, which is write once and read many model, which simplifies the data coherency and gives high throughput. Next feature is hardware failure recovery. HDFS assumes some nodes in the cluster can fail and has a good failure recovery process, which allows HDFS to run even in community failures. HDFS has failover process which can recover the data and handle hardware failure recovery. Next feature is portability. So HDFS is portable on different hardwares and softwares. The final one is computation, which is closer to data. HDFS moves the computation process toward data instead of pulling data out of computation, which is much faster as data is distributed and ideal for the MapReduce process. Next is Hive. So Hive is a SQL-like high-level language used to run queries on data stored in Hadoop, and it enables developers not familiar with MapReduce to write data queries that are translated into MapReduce jobs in Hadoop. Like Pig, Hive was developed as an abstraction layer, but geared more toward database analysts more familiar with SQL than Java programming. Hive provides a data warehouse infrastructure system for Hadoop, which creates a SQL-like wrapper interface called HiveQL, which is on top of MapReduce. Hive can be used to run some ad hoc querying and basic aggregation and summarization processing on the Hadoop data. HiveQL is not SQL 92 compliant. It was developed by Facebook and contributed to Apache. Hive is designed on top of MapReduce, which means a HiveQL query will run the MapReduce jobs for processing the query. We can even extend HiveQL by using user-defined functions. Next being the features of Hive. So it stores schema in a database and processes data into HDFS. It is designed for OLAP, online lateral policy processing. It provides SQL type language for querying called HiveQL or HQL. It is familiar, fast, scalable, and extensible. Next is HBase. HBase is a column-oriented NoSQL database built on top of HDFS. HBase is used for fast read-write access to large amounts of data. HBase uses Zookeeper for its management to ensure that all of its components are up and running. HBase is a sorted map which is sparse, consistent, distributed, and multidimensional. In addition, it provides faster lookup and also high volume inserts or updates of a random access request on a high scale. The HBase schema is very flexible and actually variable, where the columns can be added or removed at runtime. HBase supports low latency and strongly consistent read and write operations. It is suitable for high-speed counter aggregation. Many organizations or companies use HBase, such as Yahoo, Adobe, Facebook, Twitter, and many more. With that, let us see what a Spark is all about. It is a high-performance processing framework for in-memory analytic computational processing that is often used for real-time querying. And it is a powerful alternative to Hadoop's MapReduce. So let us see the features and capabilities of Spark. It is process iterative, and it has many functions and operators that's available for data analysis. DAG framework to design functions easily. In-memory based intermediate storage. It is easy to use and maintain. It is written in Scala and it's running in Java virtual machine. Applications using Spark can be written in Scala, Java, Python, R, and runs in environments such as Hadoop and Mesos, or it can be standalone or even in cloud. So let us see some of the difference between HDFS and HBase. HDFS is a storage layer for Hadoop, and it is suitable for distributed storage and processing. That is, while the data is being stored, it first gets distributed and then it is processed. HDFS provides streamlining access to file system data, and it also provides file permission and authentication. HDFS uses a command line interface to interact with Hadoop. So what stores data in Hadoop? It is the HBase which stores the data in HDFS. So let us see what is HBase. It is a NoSQL database or non-relational database. It's important and mainly used when you need random, real-time read or write access to your big data. It provides support to your high volume of data and high throughput. In an HBase, a table can have thousands